Europa, one of Jupiter's moons, was long thought to be a frozen, unchanging world. But recent observations have unveiled a startling truth. Beneath its icy crust lies a dynamic environment, reshaping our understanding of this distant moon. The James Webb Space Telescope has detected rapid changes on Europa's surface, suggesting active geological processes and a subsurface ocean. These revelations not only challenge previous assumptions, but also raise the tantalizing possibility of life existing in the hidden depths of this icy world. If confirmed, Europa could join a short list of celestial bodies in the solar system, like Enceladus and Titan, where conditions may be right for biology. And that changes everything we know about where life might thrive. The question is no longer just whether Europa harbors water, it's whether it harbors something alive. A distant moon once thought to be dead may in fact be whispering the story of life through shifting ice and chemical trails etched in the frost. In May 2025, a team led by planetary scientist Dr. Ujjwal Raut at the Southwest Research Institute published groundbreaking findings in the Planetary Science Journal. Using the extraordinary precision of the James Webb Space Telescope's near-infrared spectrograph, or NIR spec, the team was able to study Europa's surface composition with unprecedented clarity. The James Webb Space Telescope is not just an optical marvel, it is a molecular detective. It can identify specific chemical bonds by the way they absorb and reflect light, even across the staggering void between us and Europa, over 400 million miles away. What they found was remarkable: a mosaic of crystalline and amorphous ice distributed across the surface. Crystalline ice, often formed through slow cooling or recent geological activity, appeared alongside amorphous ice, which forms when radiation bombards frozen surfaces, disrupting their structure. This contrast pointed to Europa's surface being geologically active, not just in the distant past, but today. Even more intriguing was the detection of carbon dioxide concentrated in the chaotic terrains of Terra Regio, a geologically disturbed area thought to be one of the moon's youngest regions. Since CO2 cannot survive long on the surface due to the harsh radiation from Jupiter, its presence implies recent resurfacing, likely involving material from the ocean below. These discoveries echoed earlier hints from Galileo spacecraft data, but Webb's observations turned speculation into sharp resolution. We are no longer guessing, we are witnessing. It also supports the idea that Europa's ice is not a static shell, but a conveyor belt, constantly churning and delivering chemical exchanges between the frozen surface and the alien ocean below. Europa orbits within Jupiter's intense radiation belt, a region filled with charged particles that can rapidly degrade surface features. These energetic particles transform crystalline ice into amorphous ice over time. Yet Webb's data revealed crystalline structures still intact, suggesting that Europa's surface is being constantly refreshed. The fact that this refreshing may occur over weeks, not centuries, is revolutionary. Surface features that were once assumed to be ancient may actually be newborn. In cosmic terms, that's the blink of an eye. It's like standing on a frozen lake that's constantly cracking and healing beneath your feet. Except this lake hides an alien ocean deeper than any on Earth. Chaos terrains like Terra Regio, regions riddled with cracked, tilted and rotated ice blocks, may serve as conduits between Europa's ocean and its surface. These fractured regions may be places where the ice shell is thinnest, allowing materials from the salty, dark ocean to breach the surface, or for energy and chemistry to flow in the opposite direction. The detection of carbon dioxide in these terrains is critical. On Earth, carbon-based molecules are associated with biological activity. While CO2 itself is not proof of life, its presence in conjunction with geological renewal is an encouraging sign. These terrains may represent Europa's version of hydrothermal vents, places where energy and chemistry collide. And then there's the chemistry. The spectral data gathered by Webb not only pointed to CO2, but also hinted at hydrated salts, potential signs of brines leaking up from the ocean. If the ice is leaky and those leaks contain salts, then Europa's ocean is not sealed in isolation. It's chemically connected to the surface. Dr. Rout emphasized the implications. This is the most compelling evidence to date that Europa is an active ocean world, he said in a press briefing, and it suggests a greater likelihood of finding habitable environments beneath its surface. These findings also revive long-standing debates in planetary science. Just how much tidal flexing caused by Jupiter's immense gravity is enough to keep this ocean liquid? Models suggest that Europa's interior heats up as it stretches and compresses during orbit. That internal friction might power underwater volcanoes or hydrothermal vents like those found in Earth's deep oceans, places where life thrives in complete darkness. In essence, Europa is speaking to us through geology. Its chaotic ice is a language. The Webb telescope has begun translating. The implications of these findings ripple far beyond Europa. If geological activity and ocean upwelling are still occurring, it would mean Europa has the energy, chemistry, and liquid water that are considered essential for life. That elevates this Jovian moon to one of the most promising candidates in the solar system for harboring extraterrestrial organisms. NASA's Europa Clipper mission, set to launch in 2024 and arrive by 2030, is designed specifically to investigate these possibilities. It will carry a suite of 9 scientific instruments capable of mapping the surface, analyzing the ice shell, and detecting signs of ocean interaction. One of its instruments, the Surface Dust Analyzer, SUDA, will look for molecules ejected from the surface into space, potentially giving scientists a direct look at the chemistry of the subsurface ocean without having to drill through miles of ice. Another tool, the Radar for Europa Assessment and Sounding, Ocean to Near Surface, REASON, will penetrate the icy shell using radar pulses, revealing structures hidden tens of kilometers below. It could identify water pockets, brine channels, or even the boundaries of the ocean itself. And the Europa Thermal Emission Imaging System, ETHEMIS, will seek out hotspots, areas of thermal activity that might coincide with active plumes, geysers, or thin crust regions. The Clipper mission may also catch Europa in the act of venting. A plume caught mid-eruption would allow direct sampling of what lies below. It could be the closest we come to tasting the waters of another world. Together, the James Webb Space Telescope and Europa Clipper are forming a kind of planetary relay, an alliance between orbiting eyes and spacecraft scouts, chipping away at the icy enigma of Europa. If even microbial life is found here, it would be one of the most profound moments in science, a confirmation that life isn't unique to Earth, but may arise wherever the right ingredients align. Europa is no longer just a distant ice ball orbiting Jupiter. It is alive, geologically, chemically, and possibly biologically. Each new discovery chips away at the barriers separating science fiction from science fact. We are entering an era where we don't just study distant worlds, we probe their oceans, decode their chemistry, and watch their surfaces change in near real time. And as we prepare for missions that will peer deeper into Europa's secrets, we may be approaching one of the greatest revelations in human history, that life can thrive beyond Earth. So subscribe, stay curious, and keep watching the skies, because this icy moon may soon answer one of humanity's oldest questions. Are we alone?